waiting while everybody else are joining in, let's start the session. Well, good morning, good afternoon, and good evening, everyone joining us from around the world. Thank you for joining. Welcome to this masterclass. I am Smita, your host from upGrad KnowledgeHut, and it's an absolute pleasure to have you all with us today. A little bit about upGrad. upGrad KnowledgeHut is a global training organization. We have trained over 500,000 professionals in the field of agile, project management, cybersecurity, AI, among others. We have helped 4,500 plus enterprise clients in agile transformations, and we have global presence in more than 100 countries, and we are still counting. Today, we'll be talking about agentic AI and how to get ready to build your own AI agents, right? How many of us agree that AI agents and automation are the buzzwords everyone is talking about today? The reality is, automation has already become a part of most of workflows. While AI agents are talked about in today's workspaces, people are slowly embracing and getting ready to build their first one. So that's the gap we are here to close today, right? Over the next 1 hour, we will explore what agentic AI is and dive into hands-on demo of how to build an AI agent. Yeah. So before I introduce the speaker for today's session, here is something to look forward for. For those who are going to stay with us till the end, you'll be receiving exclusive discounts on our agentic AI course. Yeah. Please join me in welcoming Manas Dasgupta. He's an AI expert, educator, and a consultant. He has over 2 decades of experience in technology and leadership. Manas has experience in extensive delivery, product, and AI experience in financial services, marketing tech, HR tech, and e learning tech spaces. He also has held executive positions in leading global banks such as Royal Bank of Scotland, ANZ Bank. Manas holds a master degree in AI/ML. He leads product development on AI-enabled SaaS products. So, Manas, over to you.
Hi, Smita. Thank you. Thank you for the lovely introduction. And welcome, everybody. We've got a very healthy gathering, and good to see you all showing so much interest in agentic AI, AI development, agentic AI development. And today we are going to touch upon some of the nuances of agentic AI agents, and etc. All right. Apart, I do. I mean, as an introduction, Smita has already given a very nice introduction. I am the CTO of a US-based product company called StarWeaver, and I'm actively involved in developing a lot of agentic AI-based SaaS products in our company, as well as I have my own consulting company where we develop AI products as well. Apart from doing a lot of involved apart from being involved with upGrad since the last couple of years, developing a lot of AI programs, agentic AI programs as well. Right, so that's about myself. So I will share my screen. So I'll go full screen. So when we talk about AI agents or agentic AI, it has, as Smita mentioned, it has become a buzzword in today's world, right? Now, why has it become a buzzword? Is it all a hype or there is some reality? Um, that answer can be given, and I mean, mo every individual in the audience, each of you, want a different type of answer from that question, right? Some of you are in non-technology areas, such as you may be from a supply chain background, you may be from an HR background, you may be from a business analysis background, you may be from, say, for instance, a retail background and etc. Or you may be from a deep technology background itself, right? So for every individual, the purpose or the learning of AI holds a different meaning and different purpose, right? So for those of you who are from business domains, would actually look towards understanding what are agents, right? What can they perform? How can they automate or increase productivity in our world? So somebody from supply chain would look for, okay, can agents solve some of the problems that I am having in my domain? Can it automate some of the things that I am building, some of the applications that we are building? I mean, not me individually, through our IT team, for automating some of our processes, right? So that can be from the point of view of a business professional's perspective. There can also be some of you are also from the IT background, and you can say that, okay, I want to migrate into an AI development profession, right? So I want to recalibrate my skill and I want to get into AI agentic engineering, right? So from your point of view, the answer should be, I mean, the answer that you are looking for as to how agents are going to affect your world or agents are going to impact your world, that answer is going to be different. So you have to look for building up skills in the agentic AI or AI agents world, right? So, and we are going to see in a few bits as to how AI agents are transforming both worlds, both from the business productivity point of view or business efficiency point of view or process efficiency point of view, and also for skill development for a technology person to migrate into a more AI agent engineering world, or even if you are looking forward to automate your code development, application development, or for that matter, if you are a senior professional, senior IT professional, how you can get into AI architecting, right? So, those questions are going to be different. So, agentic AI would mean different things to um, different individual based on your profession. Right now, what is the trend actually we are having? We are seeing around us. 62% of the organizations are experimenting with AI agents. So that means lot of companies are actually curious and actively delving into what can be done using AI agents. And then when we are talking about AI agents, we are not only talking about AI agents, we are broadly talking about how large language models are going to transform the way we work, the way we do things. So it is not only AI agents, they can be RAG applications or LLM driven applications and AI agents as well. And 15%, it is expected that 15% of the enterprise workflows will be autonomous by 2028. So that apparently seems like a slow growth, but this 15% in enterprise workflows is actually a humongous amount of development that has to happen if 15% of in enterprise workflows have to be AI enabled or made autonomous partly or totally. It's going to be a humongous amount of work, and what that leaves us with is a huge amount of opportunity. Be it you are a business professional from supply chain or retail or finance backgrounds, or be it you are an IT engineer trying to migrate into the AI world, it is going to throw open a lot of opportunities for each one of us, right? So these are some of the transformation signals that are having. Enterprise software is embedding agents directly inside day-to-day work. So let's say, for instance, 3 years back, you were using a CRM software. Today, it is very likely that CRM is transformed to include a lot of AI features. Say, for instance, an AI driven extraction of reports, right? So previously, it was a traditional CRM software, and you used to click on an option, enter what filter do you want to apply on that particular CRM, and create your report. I mean, take a few steps and create your reports in the CRM. And today, maybe they have already given a feature wherein in a text box or a chat box, you type in your natural language. You don't have to learn which option, what filter, what sorting, etc., etc. Just put in a command or just put in an instruction in the chat box in natural language saying that I want a report like this. Can you build it for me? And the CRM spews out that report for you, understanding your natural language, converting that into software or instructions, technical instructions internally within the CRM, and the AI or the AI agent building your report instantly. Right? So those are the transformation signals we are looking. Pitfalls to watch out for. Why would you learn AI agent development? So when the organizations are getting into AI agent development, prototyping, tooling, etc., there are a lot of pilots which are failing because of inadequate tool design, inadequate testing, evals usage, metrics usage, inadequate policy and governance on AI, and missing observability, which are leading to inadequate results from the AI agents, which are making the tools or making the pilots fail. And this is our opportunity where there's a lot of engineers that are required in the market by organizations to take the organizations through those pilots and take into real automation within their enterprise workflows. So there's a huge amount of opportunity, be it you are a business professional, be it you are an engineer or an architect, senior professionals, etc., or a product person. It is a huge opportunity for every one of us to learn AI agents, of course, from a slightly different dimensions for each of you based on your backgrounds and your professions, and master the art of developing AI agents. Right now, there is a few levels that you need to be aware of when you are talking about AI agents, right? So let's say when ChatGPT came into picture in 2000, end of 2022, and kind of it was a storm as to it's a new kind of technology, and it kind of behaves like a human being in terms of understanding conversational language or natural language and conversing back to us in natural language, and also showing us that it knows literally everything, because those large language models are trained with the data across the internet, literally all the data across the internet. So that necessarily means that these models know everything. So you ask something, it comes back with a result. Now, how do you ask? You ask by issuing a prompt. So ChatGPT gives you a chat box, a chat text box. You write a prompt, and that prompt goes to the model, the large language model that is behind ChatGPT or Gemini or Claude, etc. And it comes back from the model through the ChatGPT interface saying that this is the response to what you wanted to know. So at the basic level, you have the prompt, and you also have the engine behind the agent that you are developing, or behind the agent that is ChatGPT or Anthropic or Claude or Gemini, etc. So there is this model, and the prompt and model interaction gives you the response. So that is at a basic level. Now, when we get onto the agentic level, and that became a evolution from the initial state of play, which was with prompts and models. We had started having various agentic frameworks, right? The initial agentic frameworks were, let's say, LangChain became very popular. LangChain is very popular till now. It's probably the most popular agent development framework at this moment. Although LangChain they themselves prefer LangGraph because they are promoting the LangGraph platform or framework more actively. So that those frameworks, the agentic frameworks or RAG development frameworks, they give us the opportunity of implementing reasoning and planning in our workflows where large language models are involved. And then at the same time, there was another evolution was happening. So in one side, agentic frameworks were coming up, which were giving us the ability to create the reasoning features and planning features in agents or LLM applications. But the other evolution that was having and that were going on is the model themselves started to implement a lot of planning and reasoning features or abilities or capabilities, right? So the combination of the agent development framework, the reasoning planning features of the agent development framework with the planning reasoning features of the models themselves give us real deep capabilities of performing very complex tasks, building agents. And at the same time, there was another gap that was found out that, okay, a model can reason. And even if the model cannot reason because it's a legacy model, an older model, I can have the reasoning done using the framework, the agent development framework like LangGraph or LangChain, etc. The gap is how can a model take action or do things with enterprise data, right? One is context. You have heard about context engineering. So one is providing context in terms of or providing the enterprise data in terms of context to the model. The second is exposing tools to access those enterprise data to bring in a variety of functionalities to the agents. And that gives us capability, external capability, and that also gives us integrations, external integrations. So for instance, you want to integrate your agent with mails. You want to integrate your agents with, for instance, Microsoft 365 or Google Workspace applications like Gmail or Google Docs or Google Sheets. You want to integrate it with messaging softwares like Telegram or WhatsApp or Slack within your enterprise or Teams. So a lot of enterprise integration possibilities came up using tools as well as data, right? And then when we started having all of those and the agent picture was getting kind of fuller and fuller or more complete and completed, we started realizing that, okay, we are starting to develop very complex agents which are autonomous, but one problem is there, which is LLM by default, or the models, large language models by default, are unpredictable. Not unpredictable in a wrong way or negative way, unpredictable in the sense, non-deterministic in the sense that if you ask the same question three times to the same model, even repeatedly, um, one after the other, it may come back with a slightly different sentence or response, right? So that means that it is quite different. So it's not going to be, it's going to be factually wrong. It is factually going to be correct and it is going to be factually same all the three times. But it's just that the sentence construction may be slightly different each of those three times. You have asked the same question to the model. So that means you need to have a way of testing this agent's responses, which is different than the traditional software testing that we are used to. Traditional software testing mechanisms are suited for testing deterministic outcomes. So that means given the same input, your traditional software spews the same output, right? All the time. The same sentence is going to come up given the same question, right? So that is not the case with agents because there is a model involved. So there are different ways of checking this, and some of the things are built within observability, evals, and with the observability monitoring and improvements, we are going to track whether our agents are performing well, if there is a drift, if the agent is consistently providing us the right answer, the same answer, or similar answer, factually same, essentially same. and keep a track of the drift, keep a track of agents' performance through observability, monitoring, and evals through testing. Right. So these are some of the things that we would implement. That is agent state. That is how data are being moved through different states of the agents in an agentic workflow. The memory. That means if you are implementing an agentic chatbot, are you also implementing memory? Because let's say, for instance, you ask a question to the agent, what is the climate of, say, Frankfurt, right, in Germany? And it comes back with the climate. And you say that, okay, can you tell me more in detail about August, right? Now is August. Now, if you ask a chatbot a question, tell me more about August, in isolation, without reference to the previous conversation, will it give you a meaningful answer? No, it will not. When I ask the question, tell me more about August, it is with memory implemented, your agent is going to remember that you asked about Frankfurt's climate in the previous question. So your next question, that is, tell me more about August, is referring to that initial question, and I will refer back to the question and the answer, that is memory, the previous conversations, and craft an answer to the new question, right? Retrieval is another thing which is implemented in a construct, large language model programming construct called, very important agentic construct, sorry, large language model construct called retrieval augmented generation. In agents, you will also have tools, tool schemas, policies, tracing, evaluation loops for testing, and so on and so forth. Some of these are really the various levels in which are implemented within your agents, and that's a kind of um, end-to-end kind of construct of that you need to follow when you are building your agents. You build in prompt and model associate models. You build in the reasoning and planning using reasoning capable models, as well as agentic frameworks like LangChain or LangGraph or Crew AI, etc., etc. You design tools, you implement observability, evals, and etc. to improve your agents, right? So these are some of the concepts. Let me check if there is any question. Not yet. All right, okay. Now, what are some of the examples? So, I mean, in the previous slide, we were going through some constructs that are going to be part of any AI agent development. However, what is an agent going to help us with, right? It's going to be all pervading. Agents are going to be all pervading. Wherever there is a process, agent can be implemented, right? For instance, customer service. Say, for instance, you are working for an e-commerce platform, e-commerce company, right? You have a website where merchandise like Amazon merchandise are sold over there. So if you have merchandise being sold on your e-commerce website, you need a chatbot which will be able to detect if you are a customer or if you are a prospective customer. Based on that, it is going to be able to craft answers to the questions that you pose. Let's say, for instance, you are a customer, you are already registered, you have logged into, I'm sorry, there is a power cut. It should come back within a minute. I'll switch up my video in the meantime. So next couple of minutes. Sorry for that. All right. So let's say, yeah. So we were talking about the e-commerce example. So you have a customer service agent on your e-commerce website, and let's say you are a customer. There's a customer who is logged in onto the site and has purchased something yesterday. Let's say not yesterday, let's say 7 days prior. And this customer is asking that the delivery date Okay, it's back. All right, so the delivery date was 2 days prior, and I am yet to receive my um, receive the product from you, right? So your agent should be able to detect which this customer is, whether the question relates to which order of this customer the question relates to, fetch the details of that particular order, see the status, see the delivery status, and come back with a response to the customer saying that, okay, I see there is a delay in the delivery, and our service center, delivery service center, has a problem, and this is going to be delivered to you tomorrow. Now that is a typical example of an agent, a customer service agent. So this is something which is going to implement a lot of smartness. This is something that the traditional software is not going to be able to do. When customer types in natural language that I have purchased this and this 7 days back, and it is yet to be delivered to me, right? Recruitment. Let's say, for instance, you are in a talent acquisition team, and you are a recruiter, you are involved in recruiting. You can have an agent that you provide a job requisition to the recruitment agent. The recruitment agent creates a JD from the requisition. It dives into, or it digs into your talent pool, that is the talent candidate database within your organization, which is there in the applicant tracking software. It pulls out the fitting or suitable candidates. It evaluates each of those suitable candidates. It creates a ranking based on the fitment, and it prepares interview plan. And it may also go along and schedule, finds out the listed interviewers suitable for this particular job from your department with the skills that are listed in the JD, and it also schedules the interviews with the interviewer, right? So this is something that the recruitment agent can do fairly autonomously. In absence of a recruitment agent, you can see that there is a lot of touch point, there is a lot of human intervention that are involved, right? So those are some of the examples. So you can have examples, agentic examples in IT operations, learning, and etc. etc. So so we will not go into a lot of examples. So these are examples for as an indicative understanding. All right. So there's a question. I'll pick it up probably. Is the observability evaluations of agents done by humans? If not, how are automated functions validating responses that are different? If the testing validation is managed by people, how do you measure and address drift? All right, so anonymous attendee, question from anonymous attendee. All right, so the answer is there are a lot of frameworks available. So let's say, for instance, for if you are developing say RAG application, there is a popular framework called Ragas, right? You can use that. Very commonly, there is a cloud-based observability tool that is used, which is from the stable of LangChain called Langsmith. So in the applied agentic AI course, we extensively use Langsmith for agent observability as well as evaluations. There are other frameworks like, let's say, Langfuse, and there are the uh, traditional observability stack that we typically use. They are also coming up with their agentic observability features. They are keeping on adding various agentic observability features as well. So if you look at Elastic Stack or Datadog, they are continuously working on bringing in agent observability. So some of these traditional ones are little less mature. some of the ones which are born as AI observability platforms like LangFuse or LangSmith, etc., or Ragas for that matter. They are more adept in kind of deep um, insights in terms of agent observability or RAG observability, etc. So that is observability. Now, evaluation is a slightly different thing. Observability is when you, after your agent has gone into production, right? Evaluation is before you send your agent to production, right? So these are testing metrics. So one thing is designing your testing metrics based on the situation or scenario that you have with your agent, the problem that your agent solves. You will design or you will come up with evaluation matrix. And then you have a choice. There are a lot of different evaluation automation frameworks. There are a lot of different matrix that are available. So let's say, for instance, if you're talking about RAG application, there are different evaluation, different evals, different set of evals. Even RAG, within RAG, there are retrieval evals and generation evals. So you will go through various kind of evals. Then you have agentic evals. So we will the course captures very extensive list of evals, and then mechanisms of how to set up automated mechanisms of those evals. So you set up automated evals. You first design the evals, you set up automated evals, and then you run your tests, and then automatically your evals will populate matrix. Say, for instance, in Langsmith. So Langsmith has a way of interacting with automated evals and creating various insights from those eval results, right? Does that answer your question? Okay, right. So, yeah, so those were some of the examples of agents. And if you have to kind of go back and kind of dive a little deeper into the construct of agents, number one is models and frameworks. So we spoke about large language model, which sits in the center of everything that we develop with LLMs, so with AI. That is RAG applications or agent application. LLM remains the main engine, right? And then there are wrappers, which are the frameworks like LangGraphs and LangChains and Crew AI and etc. They are frameworks. And then you have prompts. You create policies, you create instructions, you create roles for the LLM to play in giving the shape of the agents using the LLM. Then you attach memory to the agents so that your agent remembers the conversation. Now, memory is not a simple thing. And our course captures and it includes the various techniques of memory management, right? So the techniques of memory management can be, let's take a scenario that you have an agent and a customer is conversing with the memory. Now, the conversations can be long, the conversations can be pretty meaty. So that means that you are asking something to ChatGPT and there can be long answer. You are giving context to ChatGPT in terms of attaching a document and etc. So that means you are inflating the context. So your context size is high, your response size is high, and you are having a long conversation. Now, you expect memory to be retained. And when you have a huge amount of context or huge amount of conversational history, managing the memory becomes very, very difficult. And then if the memory becomes so big, handling that for the LLM or the agentic framework also becomes very difficult. So there are different techniques of memory management as to memory compression, information extraction, and etc. etc. Then you have RAG constructs. So RAG constructs or retrieval augmented generation has, there are multiple different ways we can perform RAG applications. So let's say, for instance, your knowledge from which your agent is going to, or your model is going to respond from, your organizational knowledge is in natural language format. Now, can you store that knowledge into a traditional database? You cannot, because it is natural language, right? So your agent or your RAG application has to understand the question and translate into an answer using the natural language knowledge that you have given it, right? And let's say that the size of the natural language is huge. In that case, what do you use? You create a RAG application using something called, that is called a vector database. You convert your natural language information into something called embedding vectors. You upsert those embedding vectors into vector databases, and then you construct your RAG application, which can then answer questions from those vector databases. All right, then you have tools, and you have policies, you have evals. We have spoke about a little, and you also have tools which give the agent the capabilities, right? So with that, it's a lot of theory. It must be starting to get a little bit boring, although there's a lot of information. What we will do is that we will get out of this PPT and try to do something which is hands-on. Let me see if there is any more question. Uh, Answered. Okay, right. So what I'm going to go do is take you to a software called Any10. Okay. If you search for Any10 on your Google and go to any10.io, you will come to this site. Okay. I would urge you to explore Any10. It's a very, very powerful visual agent development tool. All right, so you can see AI agents and workflow, you can see and control, build visually, go deep and code, connect to everything, every stick. So basically this is a no code, low code platform for building AI agents and RAG application and general LLM applications, right? It also comes up with a lot of templates. You can explore that and you can start getting started with N8N. It's a very powerful tool, and it is also covered in our applied agentic AI software, right? So what we are going to do is that now the reason I'm using N8N and not a programmatic framework and our applied agentic AI is strewn with both programmatic constructs, programmatic frameworks which are developed on top of Python to develop RAG applications and agents. But we also touch upon N8N significantly because if you are not coming from a coding background, N8N and N8N like tools such as Zapier or for that matter, Make, So you can also explore Zapier here, or Make, not Make My Trip.com. Yeah. So this is another visual platform. So you can explore Zapier, you can explore Make, but as visual tools, N8N is probably the most popular and most powerful. All right. So what we are going to do is that use N8N to develop a simple agent in the chat format. All right. Okay. So what I'm going to do is I have already logged into N8N, right? Now there is one thing which is about if I am trying to create an agent, I've already said that the LLM or the large language model sits at the center of it, right? So if I have to use the model, I'm not going to get it for free, right? I have to use it from somewhere, and that's not ChatGPT. ChatGPT and using large language models through API are completely different. So you need to go to a place called platform.openai.com, create your account and create an API key before you can do that, right? So once you have an API key, which you will get from here, here is the API key, right? So from this option, you can create your API key after creating the account in OpenAI. Or if you want to use a Claude model, you go to Anthropic and create your account and then API. Or if you want to use a Gemini model, that is Google, you can go to Gemini and create your API there, right? So with that, you are ready to use a large language model from your agent, right? Once you have done that, this is the, so you have to create an account in, okay. So there's a process for installing NA10, okay. And there are a couple of different ways you can do it. One is using the NA10 cloud, which you have to pay for. I don't want to do that. So there is a self-hosted option which can be easily done using the Docker desktop on your laptop. So if you are using a laptop, you have to install Docker desktop and you have to pull something which is called the NA10 image, right? Once I pull the image, which is a very simple task by itself, my NA10 image is there and I start the NA10 image from my Docker desktop. Docker desktop installation, no big deal, just like installing any other simple software on my laptop, right? So once I have done that, my OpenAI API key is ready. I am ready to use the LLM API. I have also installed Docker Desktop and installed N8N on my laptop. I am all ready. So I'll log in to N8N, my self-hosted one, which is running on my laptop, and I'm going to go to Create Workflow. Okay, so N8N helps us creating workflows which can be agentic, right? So I'm starting with a blank canvas. So this is my blank canvas where I'm going to start building. Okay, so I am going to give it a name, say my demo agent. Okay, and the agent has to be kicked off or triggered by something. What will typically kick off an agent? A chat. So the agent needs a chat trigger, right? So if agent needs a chat trigger, I need to create that chat trigger. No problem. So I'll click on this plus sign and I will say, just type in chat. And here is this option called chat trigger. I'll click on this, just forget about it, close it. My chat trigger is created, right? Now I need my agent. Okay, no problem. I will go to this plus sign again. I'll click on AI and I'll click on AI agent over here. My AI agent is created. Not so fast. I still have to do a little bit of configuration on my AI agent, right? So I'll double click on this and there are a couple of things I need to do. I need to associate or attach a model. The AI needs to, the agent needs to have a model. So if you see down below, there is this plus sign over here saying add chat model. So I'll click on this plus sign and I'm going to search for OpenAI. And I have this option, OpenAI chat model. Okay, so I have associated the OpenAI chat model. Now it needs to associate with an account. I have already created my account. I have set it up in NA10 and I will select a model from OpenAI. Okay, so all the models that OpenAI has, it is giving me a list of all these models. Okay, so I'll click on, say, why not have a little bit of fun with the most powerful model that OpenAI has at this moment. So if I go to ChatGPT, you can see over here 5.6 Sol. And if you, this is the default model. I have a paid account though. If you search for OpenAI models, you will see 5.6 Sol is the most powerful model OpenAI has at this moment. So I'll have some fun. I have selected, where is my agent? Here. I have selected 5.6 Sol. I'm using their most powerful model and I'm just going to close this, right? So my AI agent now has the model associated with it. Okay. Now I am going to see how I can get back the response in my agent. Just one sec. All right. I'm going to click on this chat message and I'm going to click on response mode. No properties, response mode. And in response mode, I'm going to select this using response nodes and close this. And I'm going to click on this plus sign and I'm going to select chat again. And you see this option called respond to chat. Okay. So I am going to select that and that's it. I think that's about it. Parameter message is required. Wait for user reply. No. Using response notes, it should not be there. Okay. Using response notes. Saved. Should not be there. Give me one sec. Yeah, okay. All right. So that is fine. We will do it as we go. Okay, so what I'm going to do is I will save it and I'm going to execute this and say that what's the capital of France? Okay, problem executing workflow. All right, so okay. Okay. I'll explain that in a little bit. Okay, so my agent is working now. So you can see that it is accessing the model and it's going to come back with some result. Okay, so it should come back with the result over here. Yep. Okay, there's a little bit of problem. I need to debug a little bit. Okay. Okay, so it has come back saying the capital of France is Paris. So it is working perfectly. What I have done is, if I try to see it step by step, okay. So when I double click on the chat message, and there are a couple of options that you need to set, which is say response mode, settings, nothing here. In parameters, you select the options as response mode and you select this using response nodes. Now what it tells is that there is going to be a response node at the end of the agent, and whatever this workflow generates as a response is finally printed on the chat window, right? So it has to come back to the chat window, right? And this AI agent is doing nothing but taking the input, and my input was what is the capital of France, right? So it is just taking the user input and it is executing or responding to the user input, which is what is the capital of France, using the chat model, and it is giving an output. The capital of France is Paris. And that response is going to my final node, which is of response to chat type, which is slightly different than the chat trigger. So this is the trigger, which is when chat is received, the chat trigger. So when I clicked on this plus sign and selected chat, you can see that there are two chat options. One is chat trigger, which is this, and the second one is respond to chat, which is this final one. So you need this for the chat to come, or the chat response to come back here, right? So when I double click on this, what I did was I simply dragged the output from the AI agent from here. So if I just delete this, nothing is there. I'll click this, the visual agent, the visual development tool is so easy. I just dragged it from here and pasted it here, and there you go. Waiting for input, so it is not working right now. So, okay. Yeah, so it took that output from AI agent and executed to be displayed on the chat window, which has come back to saying the capital of France is Paris. Now that's just the beginning. Okay. Now, if I ask it, what's the weather in New York today? Do you think it is going to be able to answer that question? No, because the model does not have that knowledge. Okay. So it comes back saying that I cannot access the weather data for today's weather in New York City. Check the National Weather Service or weather.gov, whatever. Right? So you can go to weather.gov or a weather app, or you can give a tool, what is called a tool, to our AI agent to be able to do just that. So if I do a normal Google search, can I come up, can I get the result of what is the weather for weather in New York today? I will. So I would give a tool to the AI agent to do just that, right? So I click on tool and I would say SERP, this one, I guess. Yeah, SERP API. And I've got a SERP API account, and I will close this. And my SERP API tool is yeah, so my SERP API tool is attached. Now I'm going to go back. What is this? Changes in the workflow operator may be changed when the node is run again. Yeah, okay. All right, so I'm going to ask this again. What is the weather in New York today? Okay. Now let's see if it can come back with that result. So you can see that the tool is getting executed. So this highlighting means that the tool is getting executed. So my agent is using the tool to look outside of the model, go into the internet and search for New York's weather today. And that is successfully executed. It is constructing the output. Sometimes it may make multiple trips to the tool to find out the right answer, and which is usual. Okay. All right. So it has made 6 trips to the tool and 6 trips to the LLM to parse the information that it has received from the tool, which is a little bit excessive. But anyway, nevertheless, it has received the answer today in New York City. It is 79.79 degree Fahrenheit and partly sunny with about 20% chance of rain. Humidity, so you can see that it has come back with a lot of details about the current weather in New York today. Right, okay. So, but I still don't have memory. So if I ask it, does it remain, is this usual or deviation to the climate? Okay. Okay, so it has come back saying that if you could share the location, date, and temperature, weather event you mean, or upload the chart image, whether it's usual climate variability or anomaly on comparison. So it doesn't know. It doesn't know what I asked in the previous question, right? So we want it to know. In that case, I need to attach memory, and there is a simple memory or inbuilt memory that N8N provides, and we are going to use just that. So now I have given my agents a memory, right? So what I'm going to do is that, okay, let me ask another question. Tell me about Roger Federer. Okay. And it has come back with a lot of detail. I will expand a little bit. And you can see that it has come back with a lot of detail. And I'm going to ask it, what was his highest achievement? Now, without memory, will it recognize this command? Recognize this question? Will it recognize that I'm talking about Roger Federer? It won't, right? So let me ask this question and see if it remembers. And it does. So we have asked this question, who is, tell me about Roger Federer, and then I asked this question, what was his highest achievement, and it actually remembers the previous question and answer, and it has referred back to that because now it has memory, right? So these are some of the important constructs about AI agents. You have triggers, you have the agent itself, you have model associated with the agent, you have memory, you have tools, and all of this we have done without writing a single piece of code, right? Na10, Zapier, Make, these are very, very powerful tools which are very handy for understanding architecture about AI, agents, RAGs, etc. Not only that, they are very, very powerful in terms of creating prototypes. And even in my organization, I have two products, two solid products whose 70% of the backend are created using N8N. As 70% of the AI backends are created using N8N webhooks, N8N agents, right? So that's a glimpse of what you can, how you can actually develop an agent using a visual development tool, right? So coming back to our presentation, there is also another construct called retrieval augmented generation, which I mentioned about, where you have natural language context or natural language knowledge converted into vector embeddings, something called vector embeddings. And those are stored in vector databases for your agents or your chats to retrieve answers from there as a chatbot or agentic chatbot, right? So in the agentic applied agentic AI course, there are the RAG is covered very extensively, with starting with basic RAG, advanced RAG. There are multiple different RAG constructs like multi-query RAG, hide RAG, hypothetical document embedding, Raptor RAG, which is a kind of recursive construct of retrieval, hybrid search, metadata filters, etc. And then eval dataset, latency, observability, cost control, etc. Right, so that's RAG construct, retrieval augmented generation. I'll skip this quickly. Then also you would learn about various orchestration patterns. When you are developing agents, there are many different orchestration pattern or architectural patterns of agents. There can be router patterns, there can be a planner executor pattern, there can be a critic refiner pattern, human in the loop implementation within agentic patterns, etc. So for instance, in a router pattern, you have input coming in, then you have a router mechanism, which is routing the input to agent A, agent B, agent C. So essentially with the same input, there are three different agentic processes happening. And then there is probably going to be a consolidator agent, which is going to take the outputs from agent A, agent B, agent C, and crafting a final response. Or if you are working with planner executor agent, there is going to be a planner, which can be an agentic planner. There can be a framework based planner. Then there will be executor agents, different tasks in terms of tools and etc. and so on. Right. So there will be different orchestration patterns when you learn agents as well. Right. So this is something that we have quickly done. And then there are all important things like guardrails. Evaluation and observability, I mentioned a little bit. What are guardrails? Guardrails are, let's say, for instance, you have your chatbot on your e-commerce platform, right? That's on the web. And somebody tries to, and there will be a lot of malicious actors like cyber hackers. Okay. They will either in an automated manner or humans coming onto your website and messing with your agentic chatbot. Now, in those cases, your agent should be able to have enough controls to sense that this guy is trying to fool around. There are many different types of validations. Some are deterministic validations, which are called deterministic guardrails. Some are non-deterministic guardrails using LLMs and etc. So guardrails implemented so that a hacker cannot, or a malicious person or agent cannot mess with your agentic chatbot or agents and make use of any vulnerabilities. So there are different types of guardrails, and we will go through the different guardrails in the course. Evaluations, observability in detail, and these are an extensive list of areas that the course captures. Python, object-oriented Python, fast API, LLM fundamentals, going into various frameworks like LangChain framework, which is anyway the most popular framework right now, Agents SDK, OpenAI SDK, OpenAI Agents SDK, RAG, the various types of RAGs going into advanced RAG patterns, orchestration patterns, operations, including guardrails, evals, observability, and etc., culminating into a capstone project, right? So this is what I wanted to share with you all. And with that, I will hang around for some question if you have, and I would hand it over to.
You, Yes, thank you, Manas. Thanks for this insightful participating. I think today's session has already answered a lot of questions that most of professionals have about how to get started with building AI agents. When we started today's session, we spoke about the change. AI agents can help automate tasks across diverse workflows in different ways. But again, as mentioned, every career journey is different.